Hello to everyone and welcome to part 4 of this video series. So the part 1, 2 and 3 was taken from 2021, 2020 and 2019. So if you haven't checked that out, I'm going to put a link in the description box, and also I'm going to put a link above here. For those interested, you can just click on the card and you're going to see all the questions under differential equations. So we're going to answer 2018 in this video. This is question 1, I guess. So the question says that given the differential equation d squared y over dx squared minus 2dy dx plus y equals to 4e to the minus x, they said find the complementary function in the form y equals to f of x. And the next one, the particular integral in the form y equals to g of x. So we're going to look and finally the solution of the differential equation for which y is 0, dy dx 1 and x is 0. So now when we look at this, we have been given a differential equation, so I'm just going to copy the differential equation here. So we have d squared y all over dx squared minus 2 dy all over dx plus y equal to 4 e to the power minus x. Now this is our differential equation. To get our characteristic equation, from there we'll get a complementary. We have n squared minus 2n plus 1 equal to 0. So this is our characteristic equation. So when we look at this, we see that negative 1, the factors are negative 1 and negative 1. So that when we add it, gives us negative 2, and when we multiply, gives us 1. Therefore, we have n minus 1 and n minus 1, so which is equal to 0. So our n1 is equal to n2, which is equal to n, which is 1. So therefore, our complementary solution, y complementary, will be equal to a plus b x e to the power x, Now this is our complementary solution. Now if we want to compare our complementary solution with our particular solution, we see here clearly that our particular solution is not the same as, or our particular solution is not part of the complementary solution. So we're going to go ahead to say y particular will be equal to a e to the minus x, so that the first derivative of this function, dy dx, will simply be equals to minus a e to the minus x, and the second derivative, the squared y all over dx squared, will simply be equals to a e to the minus x. So we're going to call our first derivative equation 1, call our second derivative equation 2, and our original equation, we're going to call it equation star. So we'll say equation 1 and equation 2. In equation star, we're going to get a e to the minus x minus 2 e to the minus, so minus 2 minus, so it's going to give us plus 2a e to the minus x. Now plus y, our y should be plus a e to the minus x, so this will be equals to 4 e to the minus x. We see that e to the minus x is constant throughout, so it's going to cancel, so we'll be left with 4a equals to 4. This implies that our a is 1, so we have a value of a. Therefore our y complementary, our y particular will be equals to e to the minus x. So that's our particular solution. Basically, this is our particular solution. So this is our particular solution, and this is our value of a. So to get our general solution, we really got our complementary solution above, right? Yeah. Now to get our general solution, we see that our y general y general will be y particular plus y complementary. So this implies that our y general will simply be equals to our particular solution is e to the power x plus our complementary solution is a plus bx e to the power x. So that's our general solution, but we were given condition x was 0, y was 0, and our dy over dx was 1, if I'm correct. Okay, that's the condition. Those are the conditions there. Now, to get the solution, we're simply going to substitute it back in our general solution. So if we do that, we're going to see that our y general, y is 0, so 0 should be equals to our x is 0, therefore we have 1 plus x is 0 means that plus a. So this implies that our a in the general solution will be minus 1. So we have that. Now we are going to look for the first derivative of the general solution. So this is going to give us minus e to the minus x. Now plus, we are going to keep e to the x constant, and then we differentiate inside. So when we differentiate inside, when we differentiate a, we're going to have 0, and when we differentiate bx, we're going to have b. Now plus, so now we're going to keep a plus bx constant and differentiate a to the x, which is simply going to give us the same thing, plus bx. So this will be e to the power x. So this is the first derivative, and it was equals to 1. So we have 1 here, and since x is 0, we're going to have minus 1. Since x is 0 also here, we are going to have plus b plus, when we substitute our 0, we are going to have a. And we saw that our a is minus 1, so we're going to have 1 should be equals to minus 1 plus b minus 1, so that this will be minus 2. When it goes the other way, it becomes 3. So our b will be equals to 3. So we have our a and our b. We're simply going to go back to the general solution and we substitute our value of a and b. So that will be the exact solution. So y general now will instead be equals to e to the power minus x plus, now we'll look at our a was minus 1, and our b was 3, so plus 3x e to the power x. So that is the solution. That's the solution. So that is it for this video, and if the video was helpful in one way or the other, please just give it a like, and if you want to see more of these videos, subscribe to KET Academy YouTube channel.